Hi guys, my name is Peter C. Dogba Jr., your math tutor, and I am an instructor of mathematics at the University of Liberia. In today's lesson, we want to continue with additional problems under higher order differentiation. And like we solved in previous lesson, we solved the first 5 problems on finding the second order derivatives. So for higher order differentiation, we told you in the previous lesson is the process of finding the derivative of another derivative. So if we want to find more derivatives of a particular function, we are carrying on higher order derivative, be it the second derivative, the third derivative, the fourth, and so forth. We are carrying on higher order derivative. So let's solve additional problems. So question 6, we have y equals x divided by 1 minus x. So the first thing we need to find is our y prime. So we say y prime equals, now because this is in a fractional form, we can apply the quotient rule. When an expression is divided by another expression, you can apply the quotient rule. When an expression is being multiplied by another expression, you can apply the product rule, right? So the quotient rule says if we have y equals to u all over v, y prime is equal to v times u prime minus u times v prime all over v squared. So this formula indicates that you must hold the denominator function first, which is v. We held v constant, and we differentiated u, which gives us u prime. Minus, we hold this u now and differentiate v, which gives us v prime. Then we square the denominator. So in this problem, this is our u, and 1 minus x is our v. So the rule says we must hold 1 minus x, which is the denominator, and differentiate the numerator. The derivative of x gives us 1. So if you have issues with finding the derivative of a function, you can go back to previous lessons and review. Minus, you hold x and differentiate 1 minus x. The derivative of 1 is 0. The derivative of minus x is just minus 1. Divided by 1 minus x, then we square it. So we say this is now equal to, so this will give us 1 minus x, negative times negative is positive, x all over 1 minus x all square. So this 1 cancel, this x cancel this x, you just left with 1 all over 1 minus x all square. So that's the first derivative. Now we want to find the second derivative. So to find the second derivative, we can leave this as it is, or we can send this denominator in the numerator such that the positive 2 will change to negative 2. Or we just leave it as it is and we find the derivative. So y prime prime now gives us, so if we want to leave it like this and find a derivative, it means we must apply the quotient rule. So we hold the denominator 1 minus x squared, and then we differentiate the numerator. The derivative of 1 gives us 0. Minus, we hold 1 now and differentiate this denominator. But now, because this denominator has an expression that is raised to a power, we must apply the extended power rule. That is, we bring this power down, 2, bring the 2 down, we rewrite this expression, 1 minus x, and we subtract 1 from the power, we get 1. Then we differentiate what is inside. So the derivative of minus x is just equal to minus 1. Divided by the denominator all square. So it's 1 minus x all square. All square. So there's the denominator. The rule says we must always square the denominator. So this whole first portion goes out. So y prime prime equals. Now we can simplify right here. Negative times this negative is positive. So now you just have 2 times 1 and 2 times. So that is 2 times 1 minus x all over. Now this 1 minus x is the same 1 minus x down here. So we can just, now look here. 2 times 2 is 4. So this is 1 minus x raised to the 4th power. So if we take 1 out of it, 1 minus x, we'll be left with 1 minus x raised to the 3rd power. So this will cancel this expression, right? So we'll be left with, now this negative is not here because negative times this negative or positive. So we'll be left with 2 all over 1 minus x raised to the 3rd power. So this is the second derivative of the function. So we do the next problem. Question 7 says x, y equals to 1. Now there's a product rule. We told you if you have y equals to u times x, let's say u times v, a product, you want to find its derivative, y prime, you hold this v, this u, and differentiate v, you get v prime, plus you hold v and differentiate u, you get u prime. So this is the product rule. This is the quotient rule. So this x is representing u and this y is representing v. But mind you, y in this equation is the name of the function. So we can use implicit differentiation. Whenever we differentiate y, we must attach y prime. Also, we could just solve for y. Since this is very simple to solve for y, we could solve for y. But since in most instances, it might be difficult for us to solve for y, so let's just leave it and find its derivative. So we have x, we hold x and differentiate y, we get y prime, plus we hold y and differentiate x, we get 1. The derivative of this 1 is equal to 0. So x y prime is equal to minus y. Now we can solve for y prime. So this x and x cancel, you have y prime to be equal to minus y over x. But if you look here from the beginning, you can be able to solve for this y. Y is equal to, you divide both sides by x, y will be 1 over x. So y prime gives us minus this y now is 1 over x divide this x. So if we reciprocate and change this sign to multiplication, we have y prime to be minus 1 all over x squared. So this is our first derivative. We now find the second derivative. So y prime prime equals, now we can, in this case, we can use the power rule. Let's send this term in the numerator. So that becomes x raised to the power minus 2. We send the term up. So y prime prime equals, so we bring this entire minus 2 down, minus 2. We subtract 1 from minus 2. So y prime prime now will just give us positive 2. And then this is x raised to the power minus 3. So we can reciprocate so that we'll be able to get rid of the negative. So this y prime prime is just 2 all over x raised to the power 3. So this is the second problem. Let's move on. Solve another problem. So question number 8, y equals 1 minus x all over 1 plus x. So we can use the quotient rule because we have an expression in the numerator, expression in the denominator, something like a fraction. We can use the quotient rule. So we have y prime equals, so we hold the denominator 1 plus x, and we differentiate the numerator. The derivative of 1 is 0. The derivative of x is 1, but because of this negative, you have a negative 1. Minus, we hold the numerator now, 1 minus x, and differentiate this denominator. So the derivative of 1 is 0. The derivative of x is just 1. All divided by 1 plus x, then we square it, raised to the second power. So now we have y prime equals, we can simplify. So this time this is minus 1 minus x, and then this time this is minus 1 plus x, divided by 1 plus x raised to the second power. So this x can cancel this x. We're left with minus 2 all over 1 plus x raised to the second power. Now we find the second derivative, y prime prime. So y prime prime, you have a negative sign, we hold on to the negative sign, and we use the quotient rule, or we can use the power rule. Send this expression on top. This will give us minus 2, 1 plus x raised to the power minus 2. So we can use so we hold this negative outside. Let's just put the entire minus 2 outside. Then we can find the derivative of this one. So we bring the power down, minus 2. We rewrite what is inside the parentheses. We subtract 1 from this power. It gives us minus 3. Minus 3. Then we differentiate inside. The derivative of x is, derivative of 1 is 0, and the derivative of x is just 1. Right? So we simplify now. We have negative times negative is positive, so it's 4 all over. This 3 is negative. We can send it in the denominator, so it will be 1 plus x raised to the power positive 3. So that is it for that expression. So we do the second to the last problem. So we have 9 equals x cubed plus y cubed equals to 1. So again, we find the first derivative before finding the second derivative. So the first derivative, differentiate x cubed. Bring this power down, is x. Subtract 1 from this power is 2. Plus, again, bring the 3 down. Y, we subtract 1 from it is 2. Then we attach y prime, since y is the name of this function. All equals to 0. The derivative of a constant goes to 0. We can solve for y prime. So 3 y squared y prime equals, we send this 3x across, it becomes minus 3x squared. So we can divide both sides by 3y squared and 3y squared. So what do we have? We have y prime to be minus x squared over y squared. So we are not done. We can find the second derivative, y prime prime. Hold on to the negative. We use the quotient rule. We could also decide to use the product rule. If we send this term in the numerator, we can use the product rule. So using the quotient rule says we must hold the denominator first. So this is y squared times, we differentiate the numerator. The derivative of x squared is just 2x. Minus, we hold x squared and differentiate the denominator is 2y. Then we attach y prime because it's the name of the function. All divided by this denominator, all square. That's the rule. So we can simplify now. So y prime prime equals, now this negative times this negative will give us positive. So we can have 2 x squared y prime, and then this time this will give us negative, so it's 2x y squared, all divided by y to the power 4. Now we can simplify it further. So we know that y prime, we solved for y prime initially. Okay, y prime was, sorry, we didn't put y prime value one side. So y prime was just equal to, we differentiated this, and then when I cross, it becomes minus x squared all over y squared. So this was y prime. So we can now replace this y prime. So we have y prime prime equals 2x squared y times negative x squared all over y squared. This is it, the first one. Minus 2x y squared, all divided by y to the 4th. So this y can cancel 1 from here. You'll be left with y. And then y prime prime now will give us, this is 2x squared times x squared. So this gives us minus 2x to the 4th power divided by y. And then minus 2x y squared, all divided by y to the 4th. So we can find LCD right here. So y prime prime equals minus 2x to the 4th. That is the LCD now is just y. So y into y is 1 times the numerator is the numerator, minus 1 into y is y times this numerator, so it's 2x y cubed, times, we can reciprocate this fraction and change this sign to multiplication. We have 1 over y to the 4th. So y to the 4th and y will now give us y to the 5th. So we have y prime prime equals. Now in the numerator, we can factor out 2x. So we can factor out negative 2x. In fact, we'll be left with x cubed, positive x cubed. Negative times negative is positive, and this will just be plus y cubed all over y to the 5th power. But from the problem, x cubed plus y cubed, x cubed plus y cubed equals to 1. So wherever we see x cubed plus y cubed, we equate it with 1. So this whole thing now will just be 1. So it's 2x all over y to the 5th. So if we want to rewrite this expression in terms of only x, we can leave it as it is, right? But if we want to write it in terms of only x, the reason why you can leave it as it is because in some problems it might be very, very challenging for you to rewrite it. So you can just leave it as it is. But let's see as to whether we can just rewrite it in terms of only x. So we can solve for this y to the 5th. But y to the 5th is y squared times y cubed. We already have y cubed right here, right? So we can say y cubed is just equal to 1 minus x squared, x cubed. That is y cubed. Next, we can find y squared. So we know that y cubed is equal to 1 minus x cubed. So if we take one, we just break this y cubed apart. So it will be y, and y squared is equal to 1 minus x cubed. So we divide both sides by y. Y squared is equal to 1 minus x cubed all over y. Again, we will still have some y value within the problem. So since we cannot easily write it in terms of only x, let's just leave our answer just like this. Okay, so let's do the last problem. So question 10 says x squared plus 2xy plus 3y squared all equals to 2. So we differentiate every term. The derivative of x squared is just 2x squared, 2x. We subtract 1 from the power is just 1. The derivative of this, now here we have product rule. So we hold this 2 and use the product rule. We hold x according to the rule. Hold the first, differentiate y, we get y prime, because the derivative of y is just 1. So you just attach the y prime because y is the name of the function. Plus, you hold this y now and differentiate x, you get 1. So move on this side, 2 times 3 is 6. So you have 6y prime. The derivative of a constant goes to 0. Now we can simplify to solve for y, or y prime. So we have 2x plus 2xy prime plus 2y plus 6y prime equals to 0. So this is y prime, this is y prime. We group them on one side of the equation and send the rest of the term. Now, every term here has 2. So we can divide 2 by all terms. So we will have x plus xy prime plus y plus 3y prime equals to 0. So this y prime and this y prime terms, x y prime plus 3y prime, and then the rest of the terms we send it on the right hand side of the equation. So we have minus x minus y. So we can factor out this. If we factor out y prime, we'll be left with x here and then plus 3y, all equals to minus x minus y. So we divide both sides by this term, we have y prime to be minus x minus y all over x plus 3y. So this is the first derivative. The question says we must find the second derivative. So we differentiate for the second term. So we have y prime prime. Hold this negative. This is the quotient rule. So we apply the quotient rule. We hold the denominator x plus 3y and we differentiate the numerator. So the derivative of x is 1 minus the derivative of y is also 1, but we attach y prime. And then we have minus, we hold the numerator now, which is, okay, sorry, so this should be, both of them should be negative, right? So let's assume we have this negative to be factored out. So this is negative is being factored out. So we hold this one now and differentiate this. We have 1 plus y. And then minus, we hold the numerator now, which is x plus y. And we differentiate the denominator. The derivative of x is 1. The derivative of 3y is 3y prime. All divided by x plus 3y all square. So we have y prime prime equals, we can simplify. So if this multiplied by this one, what do we get? So let's erase this. This was for the previous problem. So if this negative multiplied by this, we will have that to be positive. So this entire thing is positive. So we can multiply. Can we multiply? Yes, let's multiply. So we have x times 1. I was just looking for a factor that is common to both terms, but there's none. So we can just multiply. So x times 1 is x, and then x times 3y prime is 3x y prime. What's the next one? Y times 1 is y, and then y times 3y prime is 3y y prime. Divided by, oh sorry. So we have the first one. This is the first term. So we multiply x times 1 again. It's just, now this negative now will be multiplied by this entire expression. So you have minus x. X times y prime is minus x y prime. 3y times 1 is minus 3y. And then 3y times y prime is minus 3y y prime. Divided by x plus 3y all square. So we can simplify. Now 3y y prime, 3y y prime, they go out. So this carry this out. And then we see as to whether this x can carry this x out. What is next? There's nothing there. So now we have y prime prime equals, this is 3x y prime. What was y prime from the beginning? Oh, so we did not put y prime one side, but we can identify y prime. So y prime was just, now remember, this was the denominator, x plus 3y. That was the denominator. So y prime was, this was negative. Now we held this one first, which is a denominator, and we differentiated this, which is a numerator. Now we held the numerator, so this was a numerator, x plus y. This was a numerator. So that was the first derivative. So we can replace now this y prime with minus x plus y all over x plus 3y. Be careful with this minus. This minus is not only affecting this x, it's affecting both x and y. And then plus y. And what's next? Minus x. And then y prime now. So it just gave us x minus x plus y all over x plus 3y. And we have minus 3y. This whole thing is being divided by x plus 3y raised to the second power. You have to be very careful with the signs when you are dealing with these problems, so that it doesn't, you don't get things mixed up. So now we can simplify. So this expression right here, y prime, is just, this is minus 3x squared and then this is minus 3xy, because this 3x times this negative times this x. 3x times this negative times this y, divided by x plus 3y. Now, if we bring this one first, we bring this one before this y, we have negative times this negative is positive, so it's x times x is x squared. So this gives us x squared. And then negative times this positive is negative. Let's say negative times this negative again is negative, is positive, times this y. So that gives us xy divided by x plus 3y. So this 1y minus 3y is just 2y. All divided by that expression. So we can change that to multiplication and just reciprocate. So it's x plus 3y all squared. Then we can find the LCD, right? We can decide to simplify this one first. So y prime prime, this is a second derivative. So we can simplify. The denominators are the same. We just take one of them, and what we do now is just add the numerators. So it's minus 3x squared plus 1s squared. So this gives us minus 2x squared, and then minus 3x squared plus 1xy. Let's say xy plus 1xy is minus 2xy, and then minus 2y. So this is 1 all over x plus 3y raised to the second power. So y prime prime equals, the LCD now for this term and this term is just x plus 3y. So x plus 3y into x plus 3y is just 1. 1 times this numerator is the same numerator. Then 1 goes into this, is this entire thing. So it's 2y times this expression. So this gives us negative 2xy, the first one. And then 2y times 3y is negative 6y squared. Times this denominator, so we can just attach it to x plus 3y all squared. Is there anything we can simplify? Yes, we can simplify these two expressions. The signs are the same, we add them. So it's y prime prime equals to minus 2x squared minus 4xy minus 6y squared all over x plus y plus 3y raised to the third power. Because the signs, the expressions are the same, we just add the powers. Okay. Now these are all negative. We can factor out the negative. If we also factor out 2, we will have x squared, and then here will be 2xy, and then this will be 3y squared. So you will see the same thing appearing here, x squared plus 2xy plus 3y squared. So y prime prime now equals, so we factor out the negative 2. So it's negative 2. And what is left is just x squared. Negative times negative is positive. 2 goes into 4 is 2 times, so it's 2xy plus 3y squared all over x plus 3y raised to the third power. So this entire expression now is just equal to 2. So y prime prime equals minus is 2 times this 2 all over x plus 3y raised to the third power. So this will just give us minus 4 all over x plus 3y raised to the third power. So this is the second derivative of this expression. If you are asked to find the third derivative, you can differentiate this one and so forth. So thanks all so much for watching. Please don't forget to subscribe to our YouTube channel. Like the video, you can share if you like, and then hit the notification button so that you receive new videos when we upload. Thank you. See you during our next class time.